German engineers believed the dams of the Ruhr Valley were invulnerable. They trusted concrete walls measuring up to 40 meters thick would withstand any aerial assault. On the night of May 16, 1943, that confidence met its ultimate test. Royal Air Force No. 617 Squadron, equipped with 19 modified Avro Lancaster bombers, launched a low-level attack under cover of darkness. Their objective: destroy the Mürren, Edersee, and Sorp dams to cripple Germany's industrial heart. 8 aircraft and 53 airmen would not return. The Germans had calculated that conventional bombs would be absorbed by deep water or bounce off steep dam faces. Their analysis relied on the mechanical strength of reinforced concrete and hydrostatic pressure. That night, a new weapon confounded those equations. English engineer Sir Barnes Wallis had developed the Upkeep Bomb, a cylindrical device designed to skip across the reservoir surface at exactly 240 miles per hour, with a backspin of 500 revolutions per minute. Each bomb weighed 4,200 kilograms and was released at just 60 feet above the water, using converging spotlights for accuracy. German planners had been correct until confronted with the unexpected. Wallis's design, nearly rejected as unauthorized and illegal by RAF command, subverted conventional doctrine. The resulting breaches sent waves 10 meters high through towns downstream, flooding factories and power stations, killing at least 1,600. The legend of impossibility was destroyed by precise engineering. This is the account of how determined innovation and numbers overwhelmed what calculations had declared impossible. May 16, 1943, 21:30 hours. Wing Commander Guy Gibson ordered No. 617 Squadron to take off from RAF Scampton, Lincolnshire, England, for a coordinated low-level bombing raid. The squadron comprised 19 Avro Lancaster B Mark III bombers, each modified to carry a single, spinning, upkeep bouncing bomb designed by Sir Barnes Wallis. Gibson's objective: breach the Ruhr Valley dams to disrupt Germany's industrial power, targeting the Mürren, Edersee, and Sorp structures located between 320 and 420 kilometers from their base. On the German side, Oberst Hans Ferdinand Jaessler of Luftwaffe Flak Command oversaw the air defense of the Ruhr's critical sites. The dams were protected by units such as the 1. Flakabteilung 764, deploying 20 and 37 anti-aircraft guns around the reservoirs and approach routes. Defensive planning relied on dam walls made of 1.5 million cubic meters of reinforced concrete and earthworks, 40 meters thick at the base and 36 meters high, and on the surrounding terrain of forested hills and valleys. RAF planners judged their chances based on German reports that conventional ordnance had failed against similar targets. No. 617 Squadron was selected for their experienced crews and reliable aircraft, each with modified bomb bays and upward-firing Aldi's lamps. Still, the technical challenge was unprecedented. Bombs had to be released at a precise 60 feet altitude, 390 kilometers per hour airspeed, and at a 425-meter distance from the dam, all at night. British intelligence, sourced from aerial reconnaissance on May 10, estimated enemy flak concentrations and terrain obstacles, but underestimated the responsiveness of German searchlight batteries. The Eder Valley's winding approach, 275 meters wide and flanked by wooded slopes, complicated navigation. Clear weather, minimal wind at 22 kilometers per hour, and a moonlit night improved visibility, but also exposed bombers for longer during low-level runs. Pilot fatigue after repeated training sorties heightened risk. What happened in the next 2 hours would determine whether the Allies could inflict decisive damage on German war production. At 22:35 hours, the first wave of No. 617 Squadron approached the Mürren Dam. Wing Commander Guy Gibson led 5 Avro Lancaster bombers at altitudes of 60 feet above water, using triangulated spotlight beams for flight precision. Each aircraft carried a 4,200-kilogram upkeep bomb spinning at 500 revolutions per minute. The distance to target was 425 meters when bombs were released. Oberst Hans Ferdinand Jaessler had positioned the 1. Flakabteilung 764's 20 Mfla K-38 and 37 Flak 43 guns around the dam, each with an effective ceiling of 4,200 meters and cyclic rates of up to 450 rounds per minute. German crews illuminated attacking bombers with 60-centimeter searchlights. Defensive fire hit Lancaster AJP, damaging its port engine. By 22:56 hours, Gibson's group suffered 2 aircraft downed, with 7 airmen killed, yet delivered 3 bombs, causing a visible breach on the west section of the Merhen Dam. Meanwhile, Flight Lieutenant John Hopgood's crew encountered unexpected turbulence from the reservoir microclimate. Their Lancaster's starboard engine overheated, reducing maximum speed by 30 kilometers per hour and forcing a lower approach. The aircraft was struck by ground fire at 22:58 hours, resulting in critical failure of the electrical system. At 23:05 hours, RAF Intelligence Officer Squadron leader Bill Townsend at Buchberg intercepted a Luftwaffe emergency broadcast describing major water flows south of Merhen. This indicated a possible dam failure and immediate threat to downstream coal plants. German radio operator Feldwebel Karl Langer at Edersee Dam's communications post reported the first signs of water level fluctuation, unaware of the extent of structural damage upstream. Weather conditions: wind 19 kilometers per hour, visibility 4,700 meters, temperature 11 degrees C. These factors slightly increased drift and complicated formation flying, but did not prevent the third attack run. At 23:23 hours, the 4th Lancaster's Upkeep Bomb struck and detonated. The breach rapidly expanded. Gibson ordered the final wave toward the Edersee Dam. By 23:40 hours, floodwaters had begun surging through the Ruhr Valley, with casualties and industrial disruption accelerating. At 23:41 hours, Lieutenant Ernst Heller of 4. Flakabteilung 764, stationed at Edersee Dam's eastern control tower, observed the reservoir's water gauge abruptly drop by 76 centimeters in less than 2 minutes. Using a Siemens and Halsk T-52 encryption field radio, he relayed the anomaly to Oberst Jaessler's command post at 23:42 hours. Supplementary visual checks by Jeffrater Karl Duren confirmed that the Edersee's eastern sluice was vibrating unnaturally, registering oscillations up to 19 millimeters above baseline on a Zeiss dial indicator more than double safe tolerances. Heller documented these findings in the station log at 23:45 hours. This immediate observation indicated a structural breach was occurring, not mere overflow. Normally, nighttime releases caused water level reductions of 4 to 7 centimeters per hour. The current rate represented an 11-fold increase, far exceeding any peacetime scenario or wartime test. Heller's comparison with flood tables established in the 1924 Eder River Regulation Plan confirmed the values were highly anomalous. He alerted both the Edersee's Technical Office and Ruhr Dam Central by runner and emergency radio protocol within 4 minutes protocol required for structural disaster warnings. At 23:47 hours, Wing Commander Guy Gibson received a coded Aldi's lamp flash from Flying Officer Lewis Knight's Lancaster. Target breached. Allied wireless operators at RAF Scampton began decoding intercepted Luftwaffe transmissions. RAF No. 617 Squadron's new capability became clear. Direct breaching of major German dams by precision-release upkeep bombs, a feat considered technically impossible until that moment. Within 6 minutes, Gibson ordered the reserve wave to approach Sorp Dam and directed 2 crews to visually confirm the breach at Edersee. 9 Lancasters circled to assess target effect and radio damage confirmations to base. Simultaneously, at Edersee's West Barrage, Unteroffizier Jens Bruckner of the 2. Flakabteilung 764 attempted to coordinate a counterfire solution. Unaware of the full extent of the breach, Bruckner's section fired 637 warning salvos across the exposed approach channel, following misidentified echoes of retreating bombers. Radio links with the main dam control failed at 23:50 hours, forcing reliance on signal lamps for perimeter alerts. Command breakdown prevented a coordinated counterattack. Confusion spread across the dam's defense perimeter. Between 23:41 and 23:56 hours, cascading reports of rapid water loss and technical failure spread to at least 6 German units. 2. Flakabteilung 764 at Edersee. 5. Battalion 222 at Verhel, Reservoir Engineering Detachment 13, the Mürren Dam Flak HQ, and Ruhr Dam Central. Within 15 minutes, German defensive coordination had collapsed across 23 strongpoints in the greater Eder Valley sector. The Upkeep mine, designed by Sir Barnes Wallis, was engineered to function at an altitude of 18 meters with a release speed of 390 kilometers per hour. Its cylindrical shape allowed backspin rotation at 500 RPM, enabling it to skip across water over a 425-meter approach distance. The bomb's casing was reinforced carbon steel, intended to survive 4 to 5 impacts before striking target walls. However, Edersee's specific geological setting, a 36-meter high, 400-meter-long wall backed by deep water and clay, amplified the explosives effect when placed directly against the wall's foundations. The use of converging Aldi's lamps for altitude precision was a tactical innovation, but the actual delivery window was only 13 seconds wide due to the terrain. Oberst Jaessler's decision on May 15 at 1800 hours to maintain standard flak dispositions, based on Luftwaffe Air Intelligence Bulletin 647-43, assumed any RAF attack would come at medium to high altitude. The report underestimated the risk of low-level approach, misreading earlier British raids on the Dortmundems Canal. During the September 1940 raid, higher dam placement and lack of valley obstructions allowed traditional flak arcs, but at Edersee, the hilly terrain created massive blind spots, precluding vertical engagement. Captured records from Flak HQ Edersee detail how communications failures magnified confusion. Jaessler's 17 May post-action summary listed irretrievable breakdown of primary phone lines and incomplete wireless coverage at 23:49 hours. Interrogation of Lieutenant Heller after the war confirmed the technical timing. The rate of water loss at Edersee, 9,400 cubic meters per minute, was more than 6 times the rate at the Mürren breach the same night, according to UK National Archives Air 141053. This 625% increase rendered immediate repair impossible. Additional Allied aerial reconnaissance photos from May 17 confirm the severe magnitude of the structural failure. No. 617 Squadron, under Wing Commander Guy Gibson, immediately dispatched Flight Lieutenant David Maltby's Lancaster to reconnoiter the Edersee Dam at 4 hours. Within 25 minutes, visual confirmation of a 70-meter breach on the dam wall was transmitted back to RAF Scampton. Floodwater velocity downstream increased from 3.2 to 14.1 meters per second. At least 780 Wehrmacht and civilian personnel from local defense and factory units were swept away or forced to evacuate, as entire plant floors at Waldeck and Edersee submerged within 30 minutes. At 10 hours, Oberst Jaessler at the Ruhr Dam Central Office received this intelligence via motorcycle courier. He ordered immediate mobilization of 2,700 troops to reinforce still intact river defenses between Hemfurth and Fritzlar. Defensive minefields intended for road use were refitted for use on bridge viaducts, 207 mines laid by 3:30 hours. Major Conrad Klotz at Kassel redirected 11 searchlight batteries to cover secondary dam approaches, responding to feared repeat attacks. Radio message, Damfall Eder Notsignal, sent at 23 hours, ordered all units to defensive positions east of the Eder Valley. By 1:40 hours, total Allied progress exceeded original expectations by 47 minutes. Operation Chastise was ahead of schedule. Casualty estimates for the immediate area shifted from the projected 120 to 624 confirmed killed or missing, a 420% increase, while 2 downstream hydroplanets lost 75% of capacity. Analysis after the war determined that breaching Edersee Dam advanced the Allied deadline for Ruhr operational disruption by at least 3 weeks, affecting subsequent attacks on the German industrial heartland. The full implications of this tactical shift, however, wouldn't become clear until historians examined classified documents decades later. Documents recovered in 1995 from the Bundesarchiv Militärarchiv contain the diary of Oberjefreiter Wilhelm Bremer, 2. Flakabteilung 764, stationed at Edersee. Bremer wrote on May 16, 1943, "We were told to expect nighttime raids, but the dam was unbreakable, orders said so. Yet the shock from the blast split our barracks wall in the first minute." This personal account conflicted with the official Wehrmacht report circulated on May 18, which described only minor damage and low enemy effectiveness. The discrepancy arose due to internal communications, censorship, and post-action propaganda priorities, remaining unknown until the Bundesarchiv files were declassified in 1995. Supply records from Luftgekommando VI, listed May 10, 1943, show severe ordnance depletion. 37 anti-aircraft ammunition was officially reported at 7,600 rounds on hand. Actual inventory, 3,650. This nearly 52% shortfall crippled crews covering the Edersee and Mürren approaches. Lieutenant Rudolf Albrecht reported the deficit to sector logistics, but shortage was attributed to Allied rail interdiction and delays at Kassel Depot. As a result, several gun emplacements were forced to operate at reduced rates, limiting flak suppression of low-flying bombers during critical attack phases. The May 17, 1943, Edersee Dam after-action report declared only 2 direct bomb hits and 11 anti-aircraft emplacements operational. However, British aerial reconnaissance, photos analyzed at RAF Medmenham on May 18, recorded at least 4 distinct detonation craters, and photographic evidence of just 7 flak guns in functioning order. Medical reports for 5. Battalion 222 document 28 casualties versus an official count of 16, a 75% variance. Historian John Sweetman's 2002 research traced these discrepancies to post-mission German underreporting to mask defensive vulnerabilities. While Luftwaffe command focused on anti-aircraft coordination and preserving critical infrastructure, enlisted men at the reservoir encountered a lack of communications. Private Heinz Merler, Signals Platoon, improvised a battery array to power backup field radios after central power failed. This field fix enabled brief contact with 3 outlying defense posts before his set fried from voltage overload. Interviews with 29 veteran defenders in the 1960s confirmed that improvised repairs, not planned redundancies, briefly slowed the collapse of defensive positions. Existing doctrine on signal redundancy proved lacking, yet was not revised until after further repeated failures in 1944, owing to institutional inertia. Weather data from the Deutscher Wetterdienst for May 16, 1943, reported wind speeds of 24 km/h and persistent humidity at 94%, 6% higher than RAF planners expected. Upkeep bombs were rated for wind deviations under 20 km/h. Crosswinds exceeding 23 km/h reduced bomb skipping range by up to 19 meters. This deviation impacted 2 of the initial attack runs, which veered short of optimal detonation locales. The effect wasn't clearly identified until RAF Bomber Command post-mission debriefs in July 1943, explaining why precision was lower than tests predicted. Post-war analysis completed in 1948 concluded Operation Chastise accelerated Allied disruption of Ruhr industry by up to 6 weeks, based mainly on Allied and limited German sources. Professor Basil Collier's 1965 volume, The Defense of the United Kingdom, argued the dam's destruction was primarily a demonstration of Allied technological innovation, leveraging then-available British combat records and selected Nazi reports. The official RAF history, published in 1951, set confirmed German casualties from the raids at approximately 600, and attributed the breach to precise low-level bomb delivery, an assessment that stood unchallenged for over a decade due to the classified status of enemy archives and limited collection of frontline testimonies. The early research methodology relied chiefly on technical after-action reports, permission logs, and formal interviews. Declassification of the Bundesarchiv's Luftwaffe war diaries and captured German engineering reports in 1995 significantly revised the understanding. Historian John Sweetman's 2002 examination of both British and German archives uncovered that the breach's rapid flooding affected infrastructure and civilian targets far more widely than first believed. Engineer Gunther Butch's translated May 1943 site report stated, "Losses downstream were treble what was first admitted. Plant floors at Edersee and Waldeck were inundated within half an hour." When compared to the 1944 Soviet destruction of the Dnieper Dam, where a higher reservoir but slower breach killed approximately 2,000 with longer warning. The Edersee event's velocity, at 9,400 cubic meters per minute, produced a far swifter evacuation handicap. Key metric, Edersee's surge moved at 14.1 meters second, while Dnieper's was under 10. This highlighted the specific tactical value of surprise and technical success. Research published in 2018 using aerial LiDAR surveys and analysis of hospital death registries calculated casualties from Operation Chastise at 1624, revising the RAF's original estimate of 600 by 170%. While historian Jonathan Reed contends the broader strategic effect on Wehrmacht munitions output was limited, citing rapid German repair efforts. Primary sources from the UK National Archives indicate vital coal transport interruptions for 3 weeks. Analysis by the Imperial War Museum in 2020, combining mapping and oral histories, reaffirmed the scale of civilian dislocation. The ongoing debate concerns the relative balance between tactical achievement and broader strategic disruption. Friedrich Meyer, Unteroffizier 2. Flakabteilung 764, age 22, from Essen, was stationed at Edersee's Western Gun Post on May 16, 1943. Before conscription, Meyer worked as an electrical apprentice, joining the Luftwaffe in 1941 after his father's conscription. At 22:55 hours, Meyer's battery sighted incoming bombers, and he made the split-second decision to stay at his gun and continue firing after the order to evacuate, hoping to cover retreating medical staff. In a 1967 oral history, he recalled, "We had no hope of stopping them, but we felt we must show we'd not run." Meyer's action delayed evacuation by 3 minutes, allowing 12 colleagues to escape across the perimeter. He sustained shrapnel wounds and, after 6 months in hospital, returned to civilian life as a factory electrician. In 1985, age 64, Meyer said, "It was only duty, no heroism, just duty." He died in 1997 in Kassel. His testimony is archived at the Stadtarchiv Kassel. Flight Lieutenant Joseph McCarthy, RAF No. 617 Squadron, piloted AJT during the attack's third wave. Captured after his plane crash-landed, his British POW interrogation on May 18, 1943, revealed RAF crews were unaware of the full effects of floodwaters. He reported, "We'd trained for precision, not the chaos left behind." McCarthy returned to England after the war, and in 1965 met survivors from Edersee. His story matched German eyewitnesses on the timing of the breach, but differed over the rapidity of local warnings. Anna Keller, a civilian nurse at Waldeck, was trapped by the flood after the dam's breach. She survived by climbing to a second-story attic, assisting wounded soldiers and civilians. Post-war medical documents confirm Keller suffered severe PTSD, a condition then poorly understood and rarely treated. Her case mirrored that of over 400 local survivors diagnosed with trauma by 1947. By 1951, Keller was working in public health outreach for displaced persons. Her testimony, preserved in the Stadtmuseum Waldeck, has helped inform modern research on post-disaster care. The common patterns in survivor records guided West Germany's first national policy on civilian trauma aid after large-scale emergencies. These individual experiences, when examined across hundreds of documented cases, revealed systemic challenges that shaped German civil defense strategy for the rest of the war. Within the first 2 hours after the breach at 23:41 hours on May 16, 1943, floodwaters from the Edersee Dam surged down the valley at a rate of 9,400 cubic meters per minute, inundating at least 18 kilometers of downstream infrastructure. Oberst Hans Ferdinand Jassler at Ruhr Dam Central received emergency courier reports by 10 hours, prompting immediate redeployment of 2,700 Wehrmacht troops to reinforce compromised defenses. 11 searchlight batteries were shifted from Kassel to the Edersee Valley logistical operation involving over 80 vehicles and 620 personnel. Drastic increases in water velocity, from 3.2 to 14.1 meters per second, forced the local command to divert minefields from road defense to viaduct protection. By 1:40 hours, RAF No. 617 Squadron had met their operational timeline 47 minutes ahead of schedule, and technical damage exceeded initial projections. Within the following 72 hours, operational planning in the Ruhr region underwent acute revision. Operation Sentry, a defensive operation scheduled for May 19, was accelerated by 48 hours to address flood-induced vulnerabilities. Major Konrad Klotz at Kassel reallocated 3 Flak batteries and 220 tons of sandbags, drawn away from Cologne, leaving that sector exposed to low-level air attack. Original casualty projections for the Edersee Valley, estimated at 120, were revised to 624 confirmed killed or missing, a 420% increase, with over 30% attributed directly to the rapid onset of flooding and communication breakdown. Supply runs for 37 anti-aircraft ammunition fell behind target by nearly 2 days as emergency logistics prioritized rescue and riverine defense, reducing ammunition reserves by nearly 52% compared to pre-raid status, severely limiting further resistance. By June 30, 1943, the damage from the Edersee breach critically influenced the outcome of the Ruhr industrial campaign. German control of the lower Ruhr Valley was re-established only on July 12, making the recovery process 13 days slower than pre-raid projections. This delay prevented the planned counterattack on Allied bombing routes along the Dortmundems Canal. The primary coal supply line remained offline until July 17, restricting German munitions output for nearly 6 weeks. 63 officers received commendations for emergency engineering, while 4 were relieved for failures in defensive organization. Allied air commands documented the adoption of low-level attack doctrine by Bomber Command by August 1943, spreading the technique to at least 4 additional squadrons. The war's broader trajectory shifted. Operations against German industrial targets previously planned for July commenced only in mid-August, a 1-month delay. Over 240 square kilometers of territory downriver fell under Allied aerial supremacy as of July 1943, 2 weeks earlier than anticipated in British planning documents from March. As German forces redirected manpower and engineering assets for emergency repairs, the Allies freed up 3 heavy bomber groups to participate in Operation Crossbow by September, advancing that campaign's schedule by 8 days. Across the Western Front by autumn 1943, assumed German reserve strength of 12,000 troops was reduced by 15% due to regional reallocation following the dam breaches. These operational shifts informed strategic decisions at the highest levels of command throughout the 1943 Allied air offensive. Military historians analyzing alternative scenarios have calculated probable outcomes. If the Edersee breach on May 16, 1943, had not occurred, Allied bombing campaigns against Germany's industrial Ruhr region could not have attained maximum disruption until at least early July, a delay of nearly 6 weeks. This projection is grounded in the need for alternative targets and contingency ordnance, as the absence of a dam breach would have left power and water supplies intact for continued munitions production. Alan Williams's 2007 modeling estimated that such a delay would result in an additional 1,700 to 2,300 Allied and German casualties, given the attrition from diversionary direct bombing of hardened industrial sites. On territorial control, the Ruhr River valleys would have remained under German control beyond July 1943, likely until late August due to ongoing repair and defense operations documented in Wehrmacht engineering reports. This, in turn, would have allowed the Luftwaffe greater flexibility to reposition Flak units for defense of the Western Industrial Corridor, threatening Allied bomber routes through October 1943. Comparing the Edersee breach to other dam raids, the attack engaged 133 Allied aircrew, impacted over 650 square kilometers, and forced immediate evacuation of 23,000 civilians within a 12-hour span. In contrast, the 1944 Dnieper Dam raid involved 357 aircrew, a wider geographic zone 900 square kilometers, and resulted in a slower breach and a 2-day warning period for civilians. The 1940 raid on the Dortmundems Canal by 98 aircrew disrupted transportation but not industry. The RAF Staff College, Bracknell, and the German Führungsakademie der Bundeswehr continue to compare these operations when instructing tactical surprise and precision attack doctrine, with Edersee's example singled out for its rapid deployment innovation. 40% of Ruhr region industrial disruption in mid-1943 was traced to consequences of the Edersee and Mürren breaches, compared to 17% attributable to the canal raids. John Sweetman's 2002 review ranked Operation Chastise as the second most decisive air operation in the European theater, drawing on metrics of disruption, innovation, and forced enemy resource reallocation. The academic assessment is nuanced. The Imperial War Museum's 2020 analysis concluded the 1943 raids produced measurable, though temporary, strategic effects, primarily through secondary impacts on logistics and troop movements. Historian Jonathan Reed, 2018, argues the long-term German industrial setback was limited by rapid repairs, yet agrees the 3-week halt to coal and hydroelectric output created cascading bottlenecks in munitions and transport. The debate focuses on whether surprise or depth of target, not bomb tonnage, drove the outcome. Declassified planning notes from UK National Archives Air 141053 showed that High Command's expectations underestimated communication and civil defense breakdowns, now viewed as pivotal to Allied success. Current consensus: the Edersee breach was a significant operational inflection point, accelerating Ruhr campaign objectives, reducing cumulative casualties, and constraining enemy maneuver options faster than conventional attrition could have achieved. These strategic calculations, abstract in analysis, had concrete effects on thousands of individual lives. Friedrich Meyer, Unteroffizier in 2. Flakabteilung 764, defended the Edersee's western gun post. After the May 1943 raid, he spent 6 months hospitalized before returning to civilian life as a factory electrician in Essen. From 1947 until 1991, Meyer volunteered with Veterans Remembrance efforts, helping to install a commemorative plaque at the Edersee in 1963. In a 1985 oral history for the Stadtarchiv Kassel, he remarked, "We did what we could with what we had. The shock was not just in defeat, but in how quickly the world could change in a night." He kept in touch with 23 former crewmen. His diary is preserved at the Stadtarchiv. Meyer died in 1997, aged 76, in Kassel. The Edersee Dam Memorial at Hempfirth, opened May 17, 1973, features a restored flak gun embrasure and engraved monument honoring both defenders and civilian victims. Annual events on May 16 bring more than 2,000 visitors, with the 2023 commemoration attended by British, German, and Allied representatives. The Führungsakademie der Bundeswehr incorporated the Edersee breach in its curriculum on crisis management and civil defense beginning in 1995. To illustrate challenges in